we have problem number 1. The value of the integral 1 upon 1 plus tan 5x dx from x is equal to pi by 6 to pi by 3 is. So let us name the integral as I from x pi by 6 to pi by 3 dx 1 plus tan 5x. Okay. So this tan 5x can be written in the form of dx upon 1 plus sin 5x upon cos 5x, or we can write it further pi by 6 to pi by 3 cos 5x upon cos 5x plus sin 5x dx. Okay. Now say this is the integral I. So we have the one of the property a to b fx dx can be written as a to b f a plus b minus x dx, right? So using this property we can write the integral I in the form I is equal to pi upon 6 to pi upon 3 cos, instead of x we can write pi upon 3 plus pi by 6 minus x to the power 5 upon, similarly here also pi by 3 plus pi by 6 minus x plus sine pi by 3 plus pi by 6 minus x dx. Okay, which is equal to pi by 6 pi by 3 cos pi by 3 plus pi by 6 is pi by 2 minus x, right? This is pi. Okay, here also cos pi pi by 2 minus x plus sin pi pi by 2 minus x dx. Okay, so cos pi by 2 minus x can be written as sin x, right? And sin pi by 2 minus x can be written as cos x. So we have from pi by 6 to pi by 3 sin 5x upon, this is sin 5x plus cos 5x dx. Now we have the expression for I as integral from pi by 6 to pi by 3 sin 5x upon sin 5x plus cos 5x dx. And above also we have one of the relation of I, that is I is equal to pi by 6 to pi by 3 cos 5x plus sin 5x. So adding this both I, we can write as 2I is equal to pi by 6 to pi by 3, okay, sin 5x plus cos 5x upon sin 5x plus cos 5x, right, dx, which is equal to pi by 6 to pi by 3 dx, or we can write it as simply pi by 3 minus pi by 6, which is equal to pi by 6. So I is equal to pi by 12, right? So from here we can say that option B is the correct one. Okay. Now moving to the next question. We have problem number 2 is if f of a plus b minus x is equal to f, then integral a to b x fx is. Let us name the integral x fx from a to b as I. Okay. Then from the property that we have used in previous question, that is fx from a to b can be written as f of a plus b minus x from a to b dx. Okay. So again we have integral I as a to b. We can write in place of x, we can write b plus a minus x into f b plus a minus x dx. Okay. Now it is given in the question that f a plus b minus x is equal to fx. So if we replace this by fx, we will be getting a plus b minus x fx dx from a to b. Okay. So now further it can be separated as a plus b fx dx minus a plus b x fx dx, right? I is equal. So if you check, this value is also I, right, from here. So we have this as a plus b times integral from a to b fx dx minus I, or we have 2I is equal to a plus b from a to b fx dx, right? So I is equal to a plus b upon 2 from a to b fx dx. So this is the value of our integral. So we have option B as the correct one. Okay. Now problem number 3. If fx is equal to integral from 1 upon x to root x cos t square dt, where x is greater than 0, then dfx upon dt is. Okay. So we have here fx is equal to from 1 upon x to root x cos t square dt, right? And we have to find what is the value of f dash x. X is not equal to 0. These three conditions are there, right? So let us name this function gt as cos t square, right? So, and suppose the relation, suppose we have integral gt dt as capital GT. So we can write d gt upon dt is equal to gt, right? This is what the definition of antiderivative is. Okay. So we have 1 upon x to root x gt dt as g 1 upon x, here it should be upper limit, so we have g of root x minus g of 1 upon x. So now this is fx, okay, this is fx. So we have f dash x as g dash of root x minus g dash of 1 by x. So what is the value of g dash t? G dash t is nothing but gt. So we can write, we have made one mistake. While differentiating this with respect to x, it is g dash times root x into differentiation of root x, that is 1 upon 2 root x. Similarly, while differentiating with respect to x, we have g dash 1 upon x into differentiation of 1 upon x, that is minus 1 by x square. So one sign minus is there, so we have plus 1 by x square, right? Now g dash t is gt, so we can replace g dash root x as g of root x times 2 root x plus g of 1 upon x times x square. This is what the Leibniz theorem is, right? So we have root x, g of root x upon 2x plus g of 1 upon x upon x square. So taking 2x square as LCM, we have x root x, g of root x plus 2 g of 1 upon x. Now we have g of t as cos t square. Just substituting the value of, so g of root x must be cos x and g of 1 by x must be cos 1 by x square. So substituting these values, we will be getting x root x, f dash x as x root x, g of root x is cos x plus 2 times g of 1 by x is cos 1 upon x square upon 2x square, right? So we have, from here we have option B as our correct one. Okay. Now we have our fourth question, problem number 4. The integration I as a function of m and n is given as t to the power n plus 1 plus t to the power n dt. Okay. So the expression of I m n in terms of I m plus 1 n minus 1. That is, we have to reduce the power of n and increase the power of m. Okay. So we have integration I as, let me write as I m n. I m n as from 0 to 1 t to the power m into 1 plus t to the power n dx. Okay. So it is 1 plus t to the power n. So it's not 1 plus t to the power n. It's 1 plus t to the power n dt. Cos dt. So this can be written as, by taking by part. Okay, we have we can take this as first function 1 plus t to the power n as u and dv as t to the power m dt. Okay, then if we calculate du upon dt, then it will be n 1 plus t to the power n minus 1. Since we have to find the reduced value power of, since we have to find the value of I m n in terms of I m plus 1 n minus 1. So we have to increase the power of m. That's why we have taken the second function as to the power n, because we have to integrate it, and we know the formula for integration is x to the power n plus 1 upon n plus 1. And when we differentiate, the power reduces. So we have taken this as our second function, because we have to express in the terms of n minus 1. Now from here, if we integrate both sides, then we will be getting v as e to the power m plus 1 upon n plus 1. Right? Then integration I m n is simply u dv, which can be written as uv minus integration of v du. Okay, so what is uv? uv is 1 plus t to the power n and t to the power m plus 1 upon m plus 1, and of course the limit is 0 to 1, minus integration of v du from 0 to 1. v is t to the power m plus 1 upon m plus 1, and du is n into 1 plus t to the power n minus 1 dt, right? Further, we have this as, while putting 1, we are getting 1 to the power n, 2 to the power n upon n plus 1, and putting 0, we are getting minus 1 upon n plus 1, right? This side. And this is obviously n upon n plus 1 I n plus 1 into n minus 1, right? So we have I of mn as 2 to the power n minus 1 substituting 0 on this expression, we are getting 0, right? We are not getting 1, so this is 0. Okay, so we are not getting this one, so we have the expression I mn as 2 to the power n upon n plus 1 minus n upon n plus 1 I n plus 1 n minus 1. Okay, so if we see from our option, then we are getting option A as the correct one, right? Now moving to the next question. Okay, we have to find the integral from 0 to infinity, greatest integer of 2 to the power greatest integer of 2 e to the power minus x dx. Okay, so let us draw the graph first of e to the power 2 e to the power minus x. The graph will be something like this. This value is 2, and at x tends to infinity, the value tends to 0. The value 1 is somewhat here, which is intersecting the curve at x. Let us calculate this value. So 2 e to the power minus x is equal to 1. That means e to the power minus x is equal to half, or x we can write x as ln2. So this value is log 2, ln2 base e. Now 2 e to the power minus x is between 1 to 2 when x is between 0 to ln2, right? And after that it is between 0 to 1 when x is greater than ln2. X is greater than ln2. So therefore we have greatest integer of 2 e to the power minus x will be 1 when x is between 0 to ln2. Okay, at 0 it is actually the value is 2, so let us write like that, and is 0 when x is greater than ln2, right? So we have the curve the yellow curve represents y is equal to greatest integer of 2 e to the power minus x. Okay, now we have to integrate this from 0 to infinity. That means we have to find this area. Okay, and this area is obviously 1 into ln2. That means ln2 is the correct answer. Option B is correct. Okay, now moving to the next problem. Problem number 6. The value of integral 0 to 1 mod of sine 2 pi x dx is. So we have sine 2 pi x graph like this, something like this, up to 0 to 2 pi. This value is half and this value is 1, because the period is 2 pi upon 2 pi, which is equal to 1. So this is half and this is 1. Now the graph of mod of sin 2 pi x is something like this. So we have to find this area. Okay, so 0 to 1 we can write 0 to 1 sin 2 pi x mod dx is same as 0 to half 2 times 0 to half sin 2 pi x without mod, right? Because the overall area is 2 times this area, isn't it? So we have to just integrate this function. Now 2, and the integration of sin 2 pi x is minus cos 2 pi x upon 2 pi from 0 to half, which is equal to 2 upon 2 pi minus 1 minus 1. This is minus 2 upon 2 pi. So which is equal to 4 upon 2 pi, which is equal to 2 upon pi. So option B is correct, right? Okay. Now moving to the next problem. The curve y is equal to x square minus 7x plus 10 intersects the x-axis at points A and B. Then the area bounded by the curve and the line is. We have the curve y is equal to x square minus 7x plus 10, which can be written as x minus 2 into x minus 5. Now the point of intersection on x-axis is x is equal to 2 and x is equal to 5, right? So we have curve something like that. Okay, this value is 2 and this value is 5. So the question is asking the area bounded by the curve and the line AB. So question is asking about this area. So we have to find this area. Okay. So this area is the integration of curve x square minus 7x plus 10 from 2 to 5 dx. Modulus of that, the area is, right? So if we follow the integration, then A is equal to integration x square. Integration of x square is integration of x square is x cube upon 3 minus 7 integration of x is x square upon 2 plus 10x. Okay, from 2 to 5. So putting the value 5, we will be getting 125 upon 3 minus 7 times 25, which is 175 upon 2 plus 50 minus 2 cube upon 3, that is 8 upon 3 minus 2 to the power 2 upon 2, which is 14 plus 20. Now this area is 125 minus 8, 117 upon 3, right? Minus 175 by 2 is 87.5, right? Plus 50 minus 20 is 30 plus 14. Okay. 117 upon 3 is 39. This value is 39. So 39 plus 30 plus 14 is 3, 9 plus 4, 13, 3, 6, 2, 8, 83. So we have 83 minus 87.5. And area is of course the modulus of this value. Okay. So we have mod of this value, modulus of this value, modulus of this value, which is equal to 4.5 square unit, right? So from here we have option A as the correct one, right? Now moving to the next problem. The area in the first quadrant bounded by y is equal to 4x square. X is equal to 0, y is equal to 1 and y is equal to 4. So we have the curve y is equal to 4x square like this. Okay. And the line x is equal to 0 is y axis itself. The line y is equal to 1 is line this, which cuts this at x is equal to y is equal to 1. That means x is equal to 1 by 4. So this point is half. And y is equal to 4, which cuts this point at x is equal to 1. So basically we have to find this area from y is equal to 1 to y is equal to 4. So let us represent the function y is equal to 4x square in terms of x is equal to as a function of y so that the function will be in first quadrant. So we can represent as x square is equal to y upon 4 and x is equal to half of root y. Okay. So the area is half of root y dy from y is equal to 1 to 4. Okay. So we have the integration of root y, that is y to the power 1 by 2 will be y to the power 1 by 2 plus 1 upon 1 by 2 plus 1, which is equal to y to the power 3 by 2 upon 3 by 2. That means 2 upon 3 y to the power 3 upon 2. So we have a as 1 upon 3, half times 2 upon 3 is 1 upon 3, y to the power 3 upon 2 from 1 to 4. That means 1 upon 3, 4 to the power 3 upon 2 minus 1, which is equal to 1 upon 3, 4 means 2 square. So 2 cube minus 1, that is 8 minus 1 is 7 into 7. So 7 by 3 square units is the required area, which is 2 and 1 by 2. Option C is correct, right? Moving to the next problem, we have the area bounded by line. The area bounded by y is equal to ln x, the x axis, and the ordinate x is equal to 0 and x is equal to 1. So we have the curve y is equal to ln x, and the ordinate x is equal to 0 is this, and x is equal to 1 is this, and x axis is this axis. So we have to find this area. Okay. So this area is basically the integration of ln x dx from 0 to x is equal to 0 to 1, and we have to take the modulus. So first we have to find the indefinite integration for ln x, because we have to evaluate its definite integration. So ln x dx can be evaluated by using by part. Again we will be taking function u as ln x and dv as dx. So we can write du as dx upon x, and integrating this dv and dx, we have v is equal to x. Okay. So we have integration of ln x dx is equal to integration of u dv, which is equal to uv minus integration of v du. So what is u? U is ln x and v is x. So x ln x minus integration of v du. V du is v is x and du is dx upon x, that is x will be cancelled, so simply dx. So further we have x ln x minus x, that means taking x as common, ln x minus 1 as indefinite integral. So from 0 to 1, ln x dx can be written as x ln x minus 1 from 0 to 1. That means at value x is equal to 1, ln 1 is 0, right? So we have minus 1 minus limit x tends to 0, ln x minus 1 upon 1 upon x. Okay. which is equal to this value is equal to 0 if you see the limiting value. So this integration is equal to 1 and area is the absolute value of that integration, which is equal to plus 1. So we have option A as the correct one. Okay. Now moving to the next problem. The area bounded by y is equal to mod x upon x, the signum function. This function is called signum function. So y is equal to mod x upon x, which is equal to 1 when x is greater than 0, minus 1 when x is less than 0, and it is actually we have not defined at x is equal to 0. So this is the value. So we have the signum function like this, and the curve y is equal to x cube, which is like this. The area bounded by y is equal to mod x upon x, and the curve y is equal to x cube. So we have this area bounded by the curve, right? So y is equal to x cube can again be written as x is equal to y to the power 1 by 3, and this value is 0 and this value is 1y. So the area is 2 times this area. Okay, so we have 2 times area y cube dy from 0 to 1, okay, which is equal to y to the power 1 by 3 plus 1 upon 1 by 3 plus 1, 2 times from 0 to 1, which is equal to 2 times 1 by 3 plus 3 by 3, 4 by 3, which is 3 by 4, 3 by 4, y to the power 4 by 3 from 0 to 1, which is equal to 3 by 2, right? So we have 3 by 2 as our correct answer. Okay. So this is the last problem, I guess. So in next module we are going to study differential equation. Thank you.